Hello viewers, welcome back to a tutorial on AgentGrid. In this video, we'll be talking a very important component of AI AgentGrid known as ServiceGrid. So to know more about ServiceGrid, you can go to servicegrid.id GitHub. We have a documentation over there. So what is ServiceGrid? Basically, ServiceGrid is an open tool ecosystem. It's a part of a ecosystem of AgiGrid. Basically, ServiceGrid is a distributed ecosystem for functions, services, and tools, which can be used in AI or multi-agent systems. I'll not go through explaining each and every points in this README, so you can go through it. But I'll be more interested in yeah, using the ServiceGrid and displaying, creating a demo out of it. So on high level, the ServiceGrid is a protocol-driven, policy-aware, distributed execution fabric for computational assets, including functions or APIs or service or any tool calls. It provides a global registry. The moment it has a registry, you can definitely do a search or a query of the tools or a functions or a services, and runtime distributed orchestration layer where every function is a or a server a service becomes an first class, discoverable and composable entity. So this is the service grid. So we'll be talking in the usage of the service grid. So it has several components within it. So functions, API, service, tools. So how to utilize the service grid. So in the service grid, we have what are the core capabilities of service grid. We have service bank. In that, function bank, tool bank, API bank is present. So in our video tutorial, we'll be dealing in this video tutorial, we'll be dealing about tool bank. So function bank we'll be explaining in some other videos, and also the API banks. So first, let's start one sample code that we have created for usage of the service grid within the AgentGrid system. And all the codes that we are utilizing is available in the our GitHub Cosmos AI-Agent Grid. So you can go to this particular GitHub, and you can go to service grid examples. For other examples like agentic patterns and workflow examples, we have this particular folder. Right now it is service grid examples. So I'll go to service grid, and you will see a lot of folders here. So from here, agents underscore whatever you are seeing here, they are the libraries. Let's say this agent function is used for function calling, agent tools is used for agent tools calling, and agent search is for searching of agents, and agent SDK is the SDK, that SDK library that we have for integrating the life cycles of agent with the agent grid ecosystem, and agent LLM. So this is basically a library that we have created for integrating yourself with the LLMs that is hosted in AI grid or any other third party, let's say OpenAI or a Gemini. So these are our libraries. So whenever it's required, so I'll try to go into the library and I'll explain certain things in it. And we have some 4 examples lined up. So right now it's the first example that I'm dealing with. Right now it is a tool usage. So if I go inside that, you would see some folders: deploy, run, nodes, spec, tools. So in that I have a Jupyter notebook. So let me just go open the Jupyter notebook. So here, so it is about a service grid. Service grid basically has several banks. So one is a tool bank and function bank. And in the tool bank, you have basically tools usage, which can be done either via Python code or a binary code. So if you have a binary, you can upload the binary, or if you have a Python code which will do some tool calling, so we'll be writing a Python code and we'll be using it in the agents code. So that explains the tool bank and the function bank. Function bank is basically you will have a Python functions which can be deployed as an either stateful or stateless. So where stateful functions are basically we are using k8s deployment, and stateless basically will be using k8s jobs as a the backend handling. So the tools, whatever the tools bank that we run, right? So the tools code will be run within the agent code, and it shares the CPU cycles of RAM, CPU, disk of the agent pod. So the tools code, right, whether it's a Python code or binary code, they will run as a part of the agent code. Whereas the functions, since they are deployed as an separate pods within the k8s infra, it will not be taking any CPU cycles or RAM or disk of the agent pod. It will be separately hosted, it will be separately running. So k8 jobs and k8 deployment. So it will use basically the entire systems. So it can be in this node or any other node. So it will take the whole clusters, CPU, RAM, or disk. So it will not be a part of the agent pod. So we are just tapping, we are calling these functions and getting the response from them. So this is about the service grid. So we'll have we have several other examples lined up. So we'll go one by one. So this in this example, we'll be talking about the functions mainly. So how to utilize, sorry, the not functions, the tools. So how to utilize the tool, and in that tool, particularly the Python code. So we have not implemented the we have not added the binary code example yet, but we have a Python code example. So let's look into the tool back. So as I explained, the folder structure would be deploy and run nodes and spec and tools for this particular example. And so the nodes folder, so it contains the actual py file, which is basically our agent code itself. So let me just go to the nodes. So agent tools.py. So let me just go to ServiceGrid examples and tools usage. Let me just open the agent tool user.py. And in the spec file, so this spec file is basically to register this particular agent, so that anytime if you want to do an agent search or query, right, so you can basically do that. So we have a spec file. So spec file is present in the, so this is the spec file. It contains a lot of details. So what is the structure of the spec file was already discussed in several other videos. So what is important is basically its identity and the info, the container image name, the metadata, the persona, and sometime the integrations. In the integrations, currently it is a models and also a subject or tools. So these all other things are already explained in the previous video. Just to give the subject IDs, identities, subject ID, subject name, subject type, and the subject versions will be available. So these all are very important. So when you combine, if you require an URI, basically we'll be clubbing the subject ID with version and release tag, so that it becomes an unique URI for this particular agent. And this is the container register container, the container image name, and the metadata. It contains something related to subject description, what is this agent. Right now I might have put some dummy values, so search tag or a subject traits or a subject metadata. So any other things you can put it in this particular metadata field. And persona, you can put any default system messages, persona, all those things you can configure. And also you have a config where you have a parameter as one particular key in the config dictionary, and it has a lot of other parameters. So certain parameters are related to the backend system. So like inference server registry, block DB URL, inference server ID, etc. And also this his config is for human in the loop config. So right now we'll not be using it. And also here, these are also will not be using it. So tools config is basically where the configuration required for the tools access. So this is the registry, tools registry URL. Basically you will be whatever the tools you will be registering, right, so you need to register it in some registry. So that's what the tools you registry URL. So I'm loading it from the env file while registering this particular file. So these keys will be getting replaced by the env file. And this is the LLM block ID that I want to use. So what is this LLM block ID? So we'll go in checking the model sections. In the model section, there since it is an array, so you can have multiple models. And right now I'm using one model, and that model is known as OpenAI colon GPT-5.4 hyphen mini. So basically the OpenAI colon will tell that is from the OpenAI. If it is something from Gemini, you can give it as Gemini, or if it is something from the AgiGrid, we'll generally give a AIOS. So this is an OpenAI model, and you have some parameters for it, like OpenAI API key and all. So they will be replaced during the registration from the env file. So apart from this model, the one other important aspect is the subject tool. So in the subject tool, in my current example, I'll be using some three tools. So that three tools registration needs to be happening in this particular subject tool. So it is an array of dictionaries. So first is I have one tool known as agent space dot commit scribe v4. Basically this is an generate conventional commit messages from the Git and Git diffs using OpenAI. It takes the OpenAI LLM. So whatever the commit diffs we have, we'll just give it and it will take care of writing a commit message. So other thing is a log detection. So you will give a log of some transactions, and that will be analyzed by this particular agent, again with the help of OpenAI model that we are supplying, and it will generate some it generates some details like a score, severity, or a ranked root cause hypothesis, things like that. So, and also we have a third agent known as schema forge, and what it does is it infers strict JSON schema or a sample CSV schema using OpenAI, and it will try to return field documentations to it, business logic, validation rules, or anything from the data that you have given. It could be in CSV file or it could be in JSON file. So these are the three tools we have, and we'll see how to utilize those tools in our code. So, the node folder contains the main code, the agent code. The spec contains the registration file, and deploy and run consists of some scripts that is required to deploy this agent codes. So we have something known as workflow spec. Basically, we'll be deploying this piece of agent with the help of workflow, the workflow. So workflow, to know more about the workflow, how to run the workflow, what are different examples of workflow. So we have a separate YouTube videos created for that. I request you to go ahead and check those videos and then come back to understand what is workflow. So the deploy and run file contains our Jupyter notebook, the workflow spec files, and the registration files, deploying of the workflow and reviewing of the workflow, Streamlit app. So all those files is present in the deploy and run folder. And tools folder contains the scripts for tools. So let me just open that. So we have tool. So we have three tools basically, and to test this tool post registration, you can use either of this code. So I'll just open. So basically, let me show you the first three tools. So I have a commit scribe. So let me just open that. It has a code folder and it has some script files. So these script files will be doing do again registration of the tool, and building, meaning like the zipping of this particular code folder and pushing it into upload.sh is mainly to upload the file, the zip file, and we have a delete for deleting, and also you have a get.sh to check again the whether the registration is done or not. So first let me open the build.sh. So what this build.sh does is it first checks whether there is a tool.zip or agent tool.zip folder file, and if it is there, it will just remove it. Then it will zips the code folder. The code folder is present here. It creates a zip file from that code folder with the name tool.zip, and then what it does is it takes that tool.zip, it takes this spec.json, and it takes this tool.md file. All the three files together, it creates a one other zip. So that is known as agent tool.zip. It takes the spec file, it takes the tool.md, and it takes the tool.zip. So all this together becomes one bundle, and it will be zipped with the name of agent tool.zip. So this is the build.sh, and once you build it, you need to upload it. So you require basically a upload URL that is nothing but the tool registry. So we told that there is a tool registry. We have for functions, we have a function registry, agent registry. So for everything, we have separate registries. So this bash file, again, it reads the env file, and then it reads certain environment variable from it, and then what it does is it basically takes the agent tool.zip and it uploads it to the registry URL. So the URL is /tools upload. So this is the upload.sh, and in the upload.sh we are deleting also, like if any previous versions of files are available, we are calling a delete as well, so that it gets deleted, and then we are doing an uploading. And once uploading is done to so there is a delete.sh. So again, you will be basically invoking with an endpoint. So /tools agent commit scribe v4. This is the name you need to give so that it will get deleted. So let us go inside the code folder, and code folder will contain a function.py and requirement.txt. So as I mentioned, so we'll be discussing the Python version, not the binary version. So right now we are into the Python code versions of the tool bank. So in our Python code, so the code folder consists of function.py and requirement.txt. Don't change these names. So the function.py has to be the name and requirement.txt has to be the name. If you have any other files, so let's say util files or something, you can place it here, and you should make sure that the requirement.txt is added properly. As this code, this particular piece of code will be executed within the agent context. So the if any you have any new requirement.txt, so you should have it in requirement.txt. And let's go into the function.py. So this also has some particular structure. You have, it is in class with the name agent space v1 tool. So anytime you write a function.py, the class name should be this. So you should not modify the class names. And the structure is, it has an init function, and it has an execute function, and it has an execute command function. So the init function, as you can understand, it's for initialization, anything, any state variables or any initialization parameters configurations, you can do it in the init. And the execute is where the actual execution will happen from this particular function. Whenever you call this the tool, it will do basically the calling of a execute function. And this execute command is to for setting of any setting or getting any values from this particular tool when it is running. So let's say you want to change certain parameters, so you can basically use this execute command, or you want to get any values from any of like intermediate state output or something like that. If you are putting it in self dot variable, so that can be accessed via this execute command. So let's go to the init. So in the init, there are certain you will get a tool ID. So that's what the tool ID is, I think, but agent scribe, something like that, the name was there, right? This is the tool ID, and this is what it is getting, and also the tool data. So inside the tool data, you will have all of the whole registration file. So whatever the registration file is present, right? So related to the tool, so that registration files are, this is the spec registration file. So whatever is content of this tool is will be received in the tool data. And that tool data I'm initializing as a config, and from that config I'm doing several activities. So if there's the API key, I'm going to create a client, OpenAI clients. Right now I'm using OpenAI. If you have any Gemini or something like that, right? So we have other ways to handle this. If in case it is not available, so I'll initialize the client code in the later section. So let me just go to, so these are some the self variables. You can check these files later on, like where, because these are some things that is required to set and get here. So that's why I have created some variables. So in the execute, so you have an input data as on dictionary, and in this dictionary basically I'm checking with if there is a tool model, tool underscore model. So if that tool underscore model is present in the input data, then I'm going to create a I'm going to pass that tool model to create a client. And right now I told, right, I'm not going to send API key, so I'm skipping that client creation, the init itself. And since I'm getting it in input data, meaning whenever you are giving an input to it, so you need to provide the tool model, and with that I'm going to create a client. So in this create client, so create client, I will basically check whether it is an OpenAI or an Gemini, or if in case like you are trying to integrate with AgiGrid. So whether it is an AgiGrid model, all those if and else conditions you can add, or if you have any other third party, you can do an if and else conditions. And basically then I'm formatting the parameters that is required by the model. So let's say sometime we can send a max compression token, or sometime we might send max token. So all those things we need to handle it. So I have done some if and else conditions here. And so we will create an OpenAI client if it is an OpenAI code. So OpenAI model, and since we have OpenAI colon, so I'm basically splitting that model name with a colon, and then collecting only the model name, and then that and also have a API key, so which is present in the again the model dict, which is within LLM parameters API key, and that I'll be using it to initiate the client. So if it is a Gemini, again similar same things, so no differences. Only thing is the difference is this particular piece of code. So you have a GenAI dot client. So with the help of Google SDK, we are initializing the client code. So once we create the client code, uh, so we have created the client code if tool model is available, and we get some input from the since this tool is related to the GitHub committing. So you require a repo context, you might require a branch name, so certain details might be required, so that we'll pull it and then we append it to a history, and then so we'll call a generate commit. So what this generate commit does is basically it takes those inputs and it prompt, which the prompt has basically you are an expert software engineer who writes precise git commit messages, analyze the git diff below and produce a commit message, respond only in the JSON format, and this is the format it requires. And we are basically using the given input repo context and branch name and the diff content. So we'll be just putting it in prompt, and also some again messages for a LLM to understand what it has to give, like basically like write a concise git commit messages, subject max 72 characters, etc. So basically we are putting all those inputs along with this prompt, and we are just giving it to the LLM. So if it is a Gemini model, we'll use the Gemini client models dot generate content. If it is an OpenAI, then we'll use a chat completion create. So once we get the JSON, so we are returning it back from this function, and the commit will be like a type, scope, subject, etc will be added as a history if in case it is later is required, or if you are doing something with the history, right? So and we are just appending it into the history variable, and we are just returning that content. So what all content: tool ID, calls, op, the commit message, the history length, persisted, etc, certain details that we wanted from this tool to go away out, and that we are returning it. And so these are some housekeeping steps, so right now I'll not be using it, I'll not be explaining it. So this is the core functionality of this particular piece of tool. So you have execute command where you can do a get set operations, like set of some variable, get of some variable that you can execute using execute command. So we'll tell you like how to use it. So let's say once you have registered all this, to how to register, again you have a build script, you have to build it, then you have to upload it. That becomes a the build post build, the zip file will be uploaded from uploader.sh, and also it will be registered in the tools registry. So once this tool registration is done, then you can go and run this test codes. Right now again similarly I have second function and a schema for the third function, sorry, the tool. So these tools also will be having the similar structure. So again the creations, uploading a zip file, and registering, everything remains same. So it's just that three different tools are there. I will not explain in detail about those codes. And once you have these two tools registered, you can use this tools OpenAI test.py or tools test.py to test your tools. So let me just go to the one of the both of the files. So this what this file contains, it has like for both OpenAI as well as Gemini, you can test it by enabling any of this. So right now let's say I'm going to test with OpenAI, so I'll be using this. And here I have to, I'm getting a tools registry from the environment, so it requires an env file, so it will be which will be available in the git root folder. So it reads the env file and takes whatever the necessary env variables, and then it creates an agent tools, and you have to provide the registry URL, OpenAI key or a Gemini key or a model name if anything else is required, right? So basically we can pass that, we need to create separate key in this agent tool class, and we need to send those if in case it is required. So this will, the tools variable will get activated, and sorry, it will be created, and then we are adding a new uh, details. The details that we have registered already, let's say it was a commit scribe v4, that's what was there in the spec file agent tool. So now though it is registered, to use that we need to tell the this particular tools, which is the agent tool object, we need to tell that, hey, get the details about this and keep it with you. So what this does is, add function does is, it pulls all the details related to this particular tool. So what are those details? It's about this JSON file, it's about the tool code itself, the code folder which has the requirement.txt as well as the function.py, and also the registration file, and also any MD file. So basically it will pull everything from the registry. It has the registry URL, and it will by checking the requirement.txt, it will install, because it's in Python code. It understands whether it's a Python code or a binary. If it is a binary, it doesn't have to do any requirement.txt. If it is in Python code, it will pip install the requirement.txt file. So it will basically does the necessary requirement needed for that particular tool, and this tool will be available up and running, so you can use it anytime you want. So now once the tool is added, it is available right now within this agent tool context. It has done all the requirement.txt, and also it has access to that function.py. Only thing is you need to invoke. So how to invoke? Now I'll have a tool.execute tool by id. So since I know what id have like onboarded, so I'll give those id, and as it is a tool execute by id, and the input is basically it requires a bunch of input, which is what we have explained in the execute function. The execute function requires an input data, and that input data will be passed from this is the input data. So it has some bunch of input structure like tool model, some repo context, a branch name, a def. So all these details are present in this input data. The tool model is a very important, because that will create a which model to use for tool will come from this particular structure, which model to use. OpenAI. So basically this is the structure. So if you check what is the structure, this matches nothing but when you're doing the agent registration. So if you have seen this models, so this is the same structure as this particular piece of code. So whatever you are seeing here, it is having the same structure. So basically, instead of the registration file, I'm getting it from the Python code itself. And now I'm going to call that tool by giving the ID, and this is the tool ID, and this is the input data. So it will responses printing here. So similarly, I'm executing the if you want to execute any command, you can call this execute command, and you can give the tool ID. You have to send the command and data, because the tool expects command and data. Command and data key are required for the tool to execute the execute command. If the execute, so this is for the first one, the first tool. So if you want to do the similar for second tool, you just have to enable this, and again you will do the same thing. You will add the second agent, and you will call the second agent by execute tool by id. Similarly for third agent, you will add the third agent, and you will execute the third agent. So again, the third agent, the second example, which is like CSV file, this is the JSON file. So the inputs are you will give some sort of inputs, like say this is an log file, and sample JSON. So for JSON example, so here is a sample JSON, and for CSV, so there is a sample CSV. This is the sample CSV. So this if you want to this you need to run only when after the registration. Like that is once you run the upload.py upload.sh. So once you run this upload.sh for each of these three individual tools, then you can test this tools test. And also we have a tool.openai test. So again, it has the same structure as like the previous file. You would either take the enable OpenAI or Gemini. But here what I'm doing is I'm trying to register all the three tools at once, and then I have one special. You can again test individual, like individual search tool. There is a search tool API in the tools. What it does is it is basically for searching a tool. So you will give a generic prompt. I need to generate a conventional commit message from the git if. So this is a generic prompt, and you are asking this tools object to search the necessary tool for it. So since we have three commit message, commit scribe tool, log detective scroll tool, and scheme forge tool. So what it does is it takes the help of LLM that is registered. The LLM that uses is either this LLM or this Gemini API or Open API. So whichever the API key you are enabling it, and the model name you are giving it, right, it uses that particular model to search the tool available. Since it has the registry details, and these are already registered in the registry, it basically searches, it takes the descriptions of this the tool, and it takes the description of this, whatever the tools that is already registered in the registry URL. It takes all the descriptions and it matches. A semantic match will be done, and it's not a semantic match. Basically, the LLM will take care of checking those metadata, and it will try to identify which is the best tool for handling this particular the input, the prompt. So it basically then it prints the tool ID. So the tool ID is nothing but this. And similarly, you can do for analyze application logs, identify root cause failures or something like that. When you do that, it will basically identify this. So it is for again a schema search. So we have a tool search function, and also we had a execute by tool ID as one other function in the tools, and execute command is one other command inside the tool. And the next one is a search and execute tool. So right now you have done only the search, so it will not execute, so it will simply return the tool ID, but you want to execute it as well. So if you want to do that in one command, you have a search and execute tool. So right now here is I have a git diff code. I'm just giving in generic prompt, though we have three tools already registered. I'm not asking it to choose which tool, but I'm saying in generic message, see what you can do with this data. So you are just giving an activation saying that I don't know what is this data, you just search what you want to do. So it's a very generic message. I'm not highlighting whether to use a git commit or nothing. So based on the input it has, then it identifies the tool that it wants to use. So again, it uses the LLM call. So basically search tool and execute search and execute tool both will use the LLM that was initialized in this the agent tools object creation time. And that tool, it will again do the search operation, and then with this while searching it again, it knows it packs the registries, all the tools registration description, and also it knows what is this input. Right now input is having in some the string which is a git diff. So it packs all those and it gives to the LLM, and LLM will decide, okay, since it has a git diff, maybe the git tool is what it is required. And this is basically if in case, since it is executing the tool as well, right, the tool also require an LLM. So that's what we are putting it in a tool model. So right now, since we want the LLM for a tool to execute, so I'm sending it in tool underscore model. So this is what the model name is. So basically it identifies the tool, which tool to be executed, and then it executes by sending that this particular input to the tool, and we will get a response. Similarly, we have for other examples as well. You can just uncomment and run it. So these are the two test files immediately available for your disposal. So you can use this test file after registration before adding an agent details. So right now we have just registered the tool and you have run the tool. So once this run is over, then if they are working fine, then you can go ahead and use it in a agent code. You could have used it in agent code, but again it will take a lot of time. You have to again recreate the agent files or create the agent file. So many modifications will happen. So it's better you test your tools with the help of this test script. So once the tools code is done, so I have explained the tools folder, I have explained the spec file. The spec file is the registration for the agent. Node is a Python code of the agent, and deploy and run is the workflow. So let us now go and check the nodes folder where we have a tools user code. So agent tools user.py. So basically this is an agent code. So you have to it is basically a class, and you have a main construct, and in that main that you need to pass this class, and that main is given from the our SDK agent SDK code. So this main wraps everything. So whatever it is required by this agent code to run, right, and also the housekeeping stuff that is needed by the agent the agent grid. So everything will be handled by this main. And yeah, one other important aspect is so in this service grid, so you have this agent tools, right? So I just want to show you that agent tools. And in the agent tools, you have a the Gemini tool caller or a OpenAI tool caller. If you have any other third party tool callers, so you can create, basically copy paste this file, and you just have to if they are supporting OpenAPI, there is no issues. If they are separate functions altogether, then you just have to maybe duplicate this function, and you just have to change the how the functions are called. Let's say it's for Gemini, it's a client dot models dot generate content, and you need to create some variables needed by that agent. Whereas if it is an OpenAI, so you just have to call OpenAI function, new function is created, and you are just using a chat completion create. So if any other third-party services you are using is the OpenAI compatible, then you can use this itself. If it is not, if it is something else like a Gemini or some other specific third party, then you need to just duplicate this such that you can pass those third-party details during the function running, meaning when you are testing, right? So right now I was passing OpenAI API key and Gemini API key. If in case you have any third party services you want to pass, you can just pass it, and you just have to modify this agent tools for your particular uh, the third party services. And also you need to duplicate this, and you need to import it in certain places. So this is about the agent tools. So let me go to the agent code now. So the agent code, you are importing certain important things like agent tool, agent function, his client. His client is for a human intervention system. So right now I was using it for displaying the results of each agent. So and also certain other things like agent result, agent task, or a context. So these are supplied from our library. And the agent class has a init function, and it has a preprocess function, on preprocess function, get muxer function, and on data function. These are the four functions that is very much needed, and it has to be available. And rest all are internal functions like underscore log to his or any other functions. They are internal to this only so it is not a required one. So get muxer, on preprocess, and on data, these are the four main functions. So the class function. So basically this functions in the initialization, as you can understand that it is an initialization. So you will extract certain details that is required from the registration file. So you have a registration file, whatever you require from this, you will extract it. Like say you are registering the tools, right? So you are doing a tools.add manually here. If you want to automate it, instead of manually hard coding in your agent code, you need to put a registration. So that's what we have done here. We have put that in a subject tools under the integration, and those three items are here. Basically I have to get these details, I need to get the model details, I need to get these parameters, tools config, all those, right? His config, the other parameters, API keys related to models, all those details I need to get from this particular JSON file. So that's what will happen here. Basically you have a subject and a context, and subject will have all the details related to subject, and context is related to the context. So subject will have the registration, and context will have anything you want to do, any other tools like his module, or any other let's say memory module or something like that, if you want to access, right? So then at that time you will be using self.context. If you want to use the registration details, you have a self.subject. So in that self.subject, if you can see here, persona, config, parameters, something like that you are accessing, which is nothing but uh, persona, config. So these are the keys you are trying to access here. Similarly, I'm trying to exploit the registry URL, tools config, the LLM block ID that I want to I want to use. So all those details you are trying to access. And one other important is a subject tool, and from that subject tool, I'm iterating one by one tool, and then I'm doing an the tools dot add. So the tools class, I'm registering. Yeah, the tools, the self.tools is created here based on the OpenAI or a Gemini. So I'll create the self.tools, and since this is the LLM block ID, the LLM block ID you would be giving it here, which is that LLM block ID, you want to use it for tools, the tool, whenever you are doing a search tool. So this is the block you want to use. So that's what the LLM block ID is present in the model section. This is the LLM block ID, and it basically takes that particular LLM block ID, and it creates a agent tools class. So if it is a OpenAI, then it passes the OpenAI key. If it is a Gemini, then it passes the Gemini key. So if any third party you do, you need to modify this Agent Tools class inside the Agent Tools library, as well as you need to pass that here. And we have added all those tools here. So right now, even though if your 10, 20, 30 items are there, you just have to modify this alone. Other things you don't have to modify. So basically, instead of hard coding, have used the registration content and creating the object. So once this is done, his client, I'll not be much interested to know more about his client. You have to check our other videos. So in on pre-process, you are just checking whether user request is there or not. If user request is not there, you are returning none. If user request key is there, then you are returning that task itself, whatever the task you have got in array. And then on data function is called based on this data. So since it's an array, one by one item is fixed. Right now it's only one item, so that one item will be passed on to this on data function. So this task is of agent task class, and this on data has to return the agent result, whereas this on pre-process has to return always the list of agent tasks or none. So this on data, so I got a task, I'm breaking the task, and this is like just to put into some UI Streamlit app. So I'm just dumping some data here, logging, like I'm just using the his module to display some content, so that I can use a Streamlit app later on. And right now LLM provider, so I'm from that I'll take the model name, what I have to run, what I have to use it for running the tool, and then I'm calling the tool search and execute tool. What tools can be used to analyze this data? So I don't know what is this data, but I'm using a very generic prompt similar to what we have tested in test code. I'm giving the input. The input is contains nothing but this job itself, and the tool model. Tool model is nothing but the selected tool model, which is coming from the self variable. The selected tool will be created here with the help of the self LLM block ID that you have passed in your registration, and that will be passed to execute. So this what this does, it searches the what is the input, and also what is it, what all tools are available. The LLM will be taking a decision of what tool to execute, and it will execute that, and it will respond with the response. So again, if you want to test any other tools, so I mean like APIs tool search dot tool or tools execute by ID. So if you all have want to hard code the tools usage, so you can hard code it as well. So these are other functions I have commented. Right now it's not required, so I'm sending a generic prompt to execute it. So whatever you are doing in test.py, so I have run it in a agent code. I wrapped it in an agent code as a sample reference example, and once it gets the response, I'm just returning that response. So this is the simple agent, very simple agent. So whatever the test code was there, I just moved it into a agent code. So let us see, but we'll try to run those agent files now. So first thing is you need to do an registration. Though since we have a spec file, let us do an registration. So I have to run this registry agent.sh, and once the registration is done, build tool usage and push. So what this does is it basically copies this particular file and any other requirements into a Docker container image, and pushes that image to a registry. So this is the image name. This is the image name. So yeah, so once this is done, there is only one agent code, so one pod is created. And now let us register the tools that we had. So before registration, we need to zip those individual tools. So let me just zip it. So all zips are created. So commit scribe, log detective, and schema forge, all the three files are zipped, and individual agent tool.zip files are created. In that agent tools.zip, you have a tool.zip, tool.md, and spec.json, and then we are going to upload each of the files. So in the upload function, as you have I shown you, we'll delete it first, then we'll upload it. So deletion and uploading is happening simultaneously here in this upload.sh. So once we uploaded all the files, then you want to check the details of this each file, right? You can again click on this. So it will give the details of all those the tools that you have registered. Just clear it. Basically it will give you the spec file content, and where this file is setting, like basically this zip files whatever you have uploaded, right, they would have uploaded in one certain places, and the basically it's an uploaded in some registry, and that content will be the get API will present you that. So let me just show you. Yeah, so as you can see here, so this particular source code, it's the this file is present in this particular zip. So this zip file is pushed to some endpoint, which is 3255 port, and it's in the one particular server. So so it is this service is already up by the our ServiceGrid system. So you have uploaded the zip file. Now the zip file name is something different, it cannot give the same name, and also it has registered this file. And one other important is when you are doing a registration of this tool, so the tool ID, tool tags, um, so you have a man page for this tool. uh, Tool type is local Python tool. If it is a binary, you will get something else like maybe local binary tool or something like that. So right now the tool type is local Python tool. You can give some tags to it if in case some retrieval is required. So tools metadata, right now the tools metadata is not important, it is not used by the tools system. So you can ignore the content of this tool metadata, and you can give a generic description. So this description is what the LLM uses to identify which tool to be called. And next, tool API spec. So the entry points, there are two functions, execute and execute command. And in the execute, so what is the inputs? So it has a property, and uh, it has a property and whether it is required or not. So in this required or not, diff is present, so diff is definitely required. So the in the input you need to send diff, possible repo context, or if possible branch name. If they are not available, then it's fine. So but the diff has to be present here. So the diff is a string, repo context is a string, and branch name is a string. And other things like object, array, float, all those things also you can pass on. And in the this is the input type, and in the output type you have again properties. So okay, tool ID, calls, op, commit message, history length, persisted or not, so all those details. So okay is a boolean, tool ID is a string, calls is a integer, op is a string, commit message is a object, and in that it has some other details like subject, body, breaking changes, suggested issues, or full message details are there in the committed message. So if you are not sure how the structure would be, then you can simply mention type and properties. You don't have to mention this key, you can ignore this. So you just mention type equal to object, because very nestedness, it will be very difficult to keep framing it inside this properties. Again, you if this is a type is an object, again you have to create a nested things, right? So you can just keep it as object, and you can ignore it as well. So right now commit message and history length is a integer type, and persist is a boolean type. And in this required, so definitely these items definitely required. So this is in the output side. So what is output side? When you check the agent code, you are returning certain things, right? So okay, tool ID, calls, so these are the things that you are returning it. So that's what is the output side tool registration spec. So output side tool registration spec. So we have a entry, and we have an sorry, the we have execute command, when we have a execute. So execute we have seen. Now in the execute command, again you have what are the inputs. Command is a one input. In that command, what all possibilities. So set is a one possibility, get is a one possibility. For set, what all inputs. So for inputs, key is required, which is of string type. Value by default is open close, I mean it's an we are not mentioned any values. So basically it is a structure of the this particular set. So for every command you need to give what is the input and output, because since they are command, every command will return in some different format, and every command requires some different input. So we have kept a separate input output requirement for the each command that you want to execute. So this is the tools API spec. Right now again custom action. So right now it is not required, I will not talk about this, later on we'll check this. So tool execution mode, local mode. So right now tool the tools are will run in local mode only, so we don't have an running it in somewhere or some other server or a pod or something like that. We don't have it local mode. And tool policy rule URI. If you need any sort of a policies, let's say pre-processing policy, post-processing policies, before input comes to this tool, what needs to be done. So if in case you have such kind of requirements, so you have to give that policy. I'll not deal this right now, it is an advanced concept, so we'll check it in the some other examples. So other things I will not talk about right now. So this is about the tools registration and the JSON schema, and the schema only we will be registering it. So right now I have explained the tools code as well. So we are in the demo. So let us go to the demo. So certain things like this source code link and all, the when you upload it, right, so it will take care of updating this. Though this is the same content that we have seen it in our tool registration file, certain contents which is not present here will be pushed and it will be available for your access as well. So let's say the uh, policy rule URI was available in our spec file, and same is present, and certain things like the source code link was not present in the tools file, the spec file, but it is available here because the system will take care of updating those details. So let's say so certain things that is not present here, it is present in this particular JSON file. Certain, so right now I'm seeing all the three with this get.sh. You can check whether whatever registered, whatever modified has gone and updated or not. You can check it from this get.sh API. And let us deploy an agent. So let me run the created agent. Right now I built the agent, so let me I have registered the agent as well in the earlier steps. Let me deploy this agent. So agent is deployed. So let me you can check kubectl get pods agent namespace. So right now it is few seconds back it has created an agent code, and also it has something known as executor. So executor is something related to the this pod is something related to the AgentGrid SDK. So it'll, whenever you pass the input will come here, and from there it will move on to the agent tool. And also if let's say you are doing a scaling operation, so basically this will take care of scaling of those agent code, how many agents needs to be created. So certain policies you will be putting it here, and it will take care of the scaling related jobs by this particular executor pod. So whenever you create an agent, so you will have an executor pod associated with it as well. So it has 3 containers. Executor pod will contain 3 containers, whereas your agent code contains 2 containers. One in this is a Redis container, and one is a agent code itself that you have created. So the Redis container is the communication hub for any communication to come from this guy to here, right? So the Redis will be container will be used, and other container is a agent code. So let me just log this particular tool agent code. So kubectl logs -f until last 100 lines, and agent is a namespace. This is the agent code, and agent code is present. Agent code is the container name. So when you check it, you would see basically so a lot of details. Yeah, so basically it was trying to pull all the 3 agents because you are doing an add operation of the tools, right? So when you do that, it will basically pull each agent's details, and it will try to run those requirement.txt for each. So this was for log detector, the second agent. First agent is already done. From here the second agent is going on, and similarly then it will pull the for third agent as well. So it has pulled for the third agent. So basically it will pull all the requirement txt as well as all the function.py from all the agents, and it will keep it ready to be in execution. I mean, it will keep it ready so that anytime you hit, it will get executed. So these are our system related messages, so I'll not talk about this. Basically the communications details. So right now it is waiting. So the agent code is up and running, and it's waiting right now. And let us run the now I'll run the workflow creation. So I'll not explain the what is workflow and all. So I assume that you have understood the workflow already from our other videos of workflow. So I have deployed the workflow, and this is the URL of uh, the workflow, and with that workflow I can run the input. I can pass the input. So here you can run the streamlit app also to see the output, how who is communicating, how is communication is going on, what is input is received, or else you can use the the logs as well. So let me just run it. So basically I'm passing this particular user request is a user request to the input key, and I'm passing a diff content, and the user request is what required by his tool. As you can see, if there is a user request, it processes. If not, it will return a none. So user request is what we have sent, and this the since it's a workflow manager, it gives the output of the output of each agent that you provide. Right now there is only one agent, so it has done its output. So we have calls, commit messages, history length, okay, persisted, tool ID. So these details were coming from the agent code that we have created. Sorry, not the agent code. So it was from the tool code, and the tool code was directly passed as a output to the agent as well, right? So this was the tool code, and the tool's response is directly passed without doing any modification. Right now in this example, it is an simple example. So if you want to do any modification from the tools use output, right, so you can do it, but right now I'm passing it as an job output. So that output will be coming as an output of that particular agent, which is like this. So again, the second example, I'm sending some log data, and that is also processed using the log analytics. So we have the second tool which got invoked from the same agent code, and it has called the log tool, and it has done some analysis, and it is providing some output from it. So the tool ID is a log detected before. The same input, we are not, the prompt is same, the same prompt was used. What tool can be used here? Only the data was varying, so based on that it was taking care. Let's say you have a uh, you have a two data. Let's say if input is same, but if you have a two tools which are doing almost similar jobs, like something related to git commit or something related to git stash or something like that, you have a requirement, right? Then you need to modify this prompt properly so that proper tool is picked. What I mean is, like, you have a same content, git diffs is present as a input, but if you have two tools which is doing similar operation but little bit modification, so you need to give a proper prompt. That's what the invocation is. Generally when you're dealing with the LLM tool calls, so LLM will take care of what needs to be called, which tool to be called based on its context. So right now the agent's job is to provide that context properly. So you need to take care of that. The prompt, what prompt you need to provide is what you need to take care. But in my case, I have given a very generic prompt. So that's it. The tool has run it, and the tools are executed. The tools are executed for two different input tasks. And as a housekeeping stuff, we need to, if you are not if you don't require it, the workflows and the agents, right, you can always remove it using the scripts here. So one is for removal of the workflow, and then removal unregistration of the workflow, and then removal of agents, and then unregistration of the agents. So this is just the housekeeping. So as you can see, the pods are getting terminated. There's no agent tool, sorry, the agent code as well as the executor tool also getting terminated. So that's it. So you can write your own tools, and you can uh, pass it on to our agent tool class, and it can be accessed with the help of the libraries SDKs that we have provided in the code. So whenever you want a tool usage, you need to make sure that you have this agent tools class in your a script. So this agent search is also is required. If you want to search any agents, agent SDK is a main code which is required for integration with the AgentGrid. That is definitely required. So what it definitely required is agent SDK and agent tools if you are working with the tools. So in next section we will discuss about the functions. So thanks for watching and keep supporting us.